plotting all these points. We got our zeros, 1, 2, 3, 4. Absolute max at 1.5, 2. Relative max at 2.5, 1. And then a relative min at 0.5, -3. That's the one that has a typo on it. Okay. So it should look like an M. So down and then up and then down. So in normal problems like this, you're going to have to use your calculator and find the zeros and the maxes and the mins, and you can review that stuff today if you need it. That's why on your homework there was a second video there. You needed a refresher of the calculator steps. You know what involved. Okay? Domain is going to be really obvious for these guys. Okay? Do you remember how to find your range from these values? Which ones do we kind of hone in on for range? We care about y values, and we care about which y values. The absolute max and min. Because if that's the highest I go and the lowest I go, I can figure out my range from there. So how do I write my range? Negative infinity, because there's no absolute min, up until 2. What kind of brackets are we looking at?
Brackets.
Full?
Brackets.
Negative infinity is not a number, right? That's just a concept, so it's not included, so you got to break to it softly. And 2 is a hard stop. Hard stop at 2. Okay. So increasing and decreasing we've done before. Remember what I told you to draw to make your life a little easier? You know Miss Hot loves a good number line, right? So you can kind of hone in and focus. What values are we looking at? We care about x values for all of these. That's for everything here is all about the x values. Okay? And we can grab all of our x values from here. Okay? So you just need to put them in order from lowest to highest. So what's my lowest x value of the 3 that I'm grabbing? Negative 1.5, good. Next we get 0.5, and last 2.5. What do we start off doing in this graph? Do you start off by increasing or decreasing? Increasing, right? I'm starting off, if I put my finger on it and I trace it, I'm going up. So this guy is increasing, and then they just alternate, which is really nice, makes it a little bit easier, right? So in your increasing intervals is this and this, right? You okay there? So we got negative infinity to negative 1.5. And then we can kind of go back and forth here, right? Once I stop increasing, what do I start doing? I start decreasing at negative 1.5. And you can just go through your number line that way if you want to as well. So where do I stop decreasing? At the 0.5, right? Right? We're going from here to here, then we're going from here to here, and then we pick up and start increasing again, right? What do I put in between my little doodad? The U for union, good. So I start increasing again at 0.5, and I stop where? At 2.5, good. And then I'll start decreasing at 2.5 all the way until infinity. Do you see where those values are coming from? You guys okay with that? Okay. I feel like we need some names and noise so I can talk to it. So then how do I find points of inflection? These 3 are the new ones, right? And basically we're looking at concave up and concave down. What's concave up look like? What letter does it look like when things are concave up? Looks like a U, right? We're looking for where does the graph look like a U versus concave down, where it looks kind of like an n, yeah, like a lowercase n, right? And the key here is that it's concave down here and concave down here, but then it's concave up in the middle. So our little shortcut to kind of estimate where that piece would be is to find kind of the middle of these places, right? So can I find the middle of infinity and 1.5?
Yes. No.
Negative infinity plus negative 1.5 is still negative infinity. And half of negative infinity is still negative infinity. So that's not very helpful. So we only need to worry about in between the ones that are actual numbers. Okay? And how do I find the middle of two numbers? Or how do I find the middle of a bunch of numbers? You're averaging them. Yeah, exactly. You're just averaging them together to see what you get. So I took the two spots for my maxes and mins from my increasing and decreasing number line, and I just averaged them together here. What do I get? I'm looking at negative 1.5 and 0.5. Mm-hmm. Yep.
So you would get 1 for that, and then
So yeah, negative 1.
in this case we just negative 1.
Exactly. So you've got negative 0.5 here. And then how about this guy? I got 0.5 plus 2.5 over 2. What's that give me? Remember? 3 over 2, which is probably easier in decimals here. We're going to play the approximation game for a lot of these. This is a nice decimal. What's this guy give me? 1.5. So we've got 1.5 here as well. I know that on the video I had you write these as coordinates. You can totally just do x equals, I made the executive decision in 4B. Okay? It's going to be a little bit easier. This is already kind of a lot of work, so to substitute those numbers in is a little extra, as you say. I'll never get over that one. I didn't see that one coming. Alright, so we got 2 points of inflection. So, similarly to when we do increasing and decreasing, when we talk about concave up and concave down, we're still talking about Excuse me for one moment. The poltergeist is playing games with me today. Rude. So rude. We're still looking at negative infinity to positive infinity. I'll show you. There's just a lot going on in that number line. That's a little too much for the solid to look at. So I had negative 0.5 and 1.5. So do you start off in this graph being concave up or concave down? Yeah, you're starting off as concave down, right? Until we get about there. And then here is going to be concave down as well, where this little section is concave up. Are you okay with that? Visually see it at least? Okay. So if we start off concave down, concave up, concave down. Dud. Completely indicated by that. And you write them like intervals just like you do here. So if I start with being concave down, I'm starting at negative infinity, and where does it switch over to concave up?
0.
Not at 0. At negative 0.5. Right? At this number that we found from averaging. Okay? And then if I stop being concave down, I start being concave up until when? At the 1.5. Good. And then I stop being concave up and I start being concave down again until infinity. Good. And we can walk through like an entire other problem with all the calculator steps if you want to, okay? just want to give you some time to kind of play around with these, remember how to do all the calculator stuff.
How does 1.5
Because they stop about here, it ends up being, we're averaging from here to here.
So you're just guessing?
In calculus, you'll do derivatives and all sorts of stuff to get the exact values for these. For us, just to kind of get the idea of what concave up and concave down is, we're just going to kind of average into the middle. Okay? Just to kind of see those words and be used to those words and kind of get the idea of how they're written. Okay? There are more precise ways to find it, it's just in higher level now. Okay? Good question. Does that work?